Hey everybody, so I wanted to make this video on thought overall. I have a lot of thoughts around thought and stream of consciousness and kind of what it all relates to. And so for me, I want to start off on the first place that I think of when I think of this subject, which is an experiment that I've talked about before, and I've watched it a long time ago, and it's very short to watch. So this is what we're looking at here in the center. The big yellow dot is slime mold, and then the little white dots are essentially like oatmeals. And then we're just going to watch this slime mold grow real quickly. And then the thing that I want to pay attention to is the way that it grows out, specifically like when it starts getting towards the outer kernels. To me, this is order. Order is built directly into what we're looking at here. The end result is very clearly ordered to me. There's a structure here, and it's a complex structure on some level. And this obviously has a slime mold has no brain, no mechanism to produce complex structures. Yet it does produce complex structures. And then so more recently, there was an experiment that came out with essentially a box jellyfish. This guy, this is what it looks like, and this guy is about the size of your thumbnail. So if you take your thumb and you just the nail, that's how big this guy is. So really small, and this is extremely zoomed in picture of it, but. Essentially, this organism has a very complex visual system, and then it has stimuli, of course, to interact and like feel its environment. So it can see its environment and it can feel its environment. But other than that, there's not a lot of structure to this organism itself. I think this is a good picture here that we're looking at of essentially the inside of this guy. And then so if we starting at the bottom right, we can see it's all just lenses. So it's got an upper lens and then a lower lens in its eye. And then the main structure is like just its eye. These lenses, the pit of the eye, the slit of the eye, the stalk, which is it's like kind of like legs or tentacles, and then what they call the crystal, which is just like clear. And then the last thing to point out here is the ropalia, which are kind of just like, to me, like sensors for understanding its like external environment, like feeling the environment. And then so these ropalia are very interesting because so what the scientific experiment did was they took this little jellyfish guy, and then they recreated its environment, and then essentially placed it into a tank with like painted reefs, like fake reefs. And then the little guy would go and then bump into the reefs and then essentially learned to avoid the reefs. And then they went through numerous studies to show that it was actually learning to avoid the reefs. They put it from one tank into another, and then it learned to adapt in the second tank more quickly than it would in the first. And the big thing is, and what's significant here is when they removed the ropalia specifically, like these particular parts of the organism, it couldn't learn. Like it didn't react in the same way. And then so they were able to isolate that in some way that this ropalia is kind of at least one of the, like it's a main mechanism in this creature's ability to like learn. And so the ropalia is essentially like stimulus. It's the way that the organism is recognizing the stimulus from the environment. And then it feeds through here. And then so what this kind of points to me overall, and it's kind of been a big thought of mine overall for a while, is that thought, everything that's associated with it seems to be more associated with the environment and the stimuli of the environment than an actual like structured brain. And then like carrying forward this train of thoughts, like so when we look at AI and everything associated with it, we often associate it with the human brain, and we model it after the human brain. But in a lot of ways, we don't model it after the human brain, and I think that's good overall. But it also like shows our limited understanding of these things, especially when we look at marine life. Marine life has very different brain structures than what we find in mammalian life and like vertebrae. And looking again at this jellyfish that doesn't have a brain whatsoever, no brain, and it can think. Uh, but another example of this that I like to personally look at is the octopus. And the octopus is essentially, if you look at it here, it's got a unique structure, right? So it's got the central brain, but then you can also see it's got many brains in its arms, as it's kind of laying out here. And that's kind of like what it is. Like an octopus is like a ball of sensors and stimuli for the environment, and a decentralized brain structure. Like it's just neurons, and ability to process what those neurons are feeling. And overall, the octopus brain is actually like very small compared to other creatures. Like if we do octopus brain number of neurons, and I can tell you it's around 500 million already. But we'll just show 500 million neurons. And then let's do human brain, which is I think around 180 million, 86 billion. And then we'll do like a dolphin brain. This is giving, there we go, 10 billion neurons. And then what I know is the biggest, that's probably why, what the biggest one is going to be an elephant brain. We've got 257 billion neurons. So what we can see within this and by going through this is like there's a huge range of number of neurons that we just went through and we looked at here for creatures. So elephants are at the top of the list, more than any other creature in the world. 257 billion neurons for an elephant. As far as like creatures that are considered intelligent and on that range of intelligence, octopi have the lowest amount of neurons in their brains. When we saw 500 million, you look at like a raven, for example. Raven's got about 1.8 billion. So, like triple or more the amount of neurons in its brain than an octopus has. But there's more and more talk that octopus brains are like octopi could be one of the top 3 smartest animals in the world. There's debate over if it's like in that realm of like dolphins and ravens, if it's above them, below them, where exactly it is. But the prevailing thought is that like octopi are conscious, that like they very clearly show conscious traits, that they have that ability of intelligence. And that ability of intelligence doesn't come from the size of their brain. It comes from the shape of their brain, the structure of the brain, the fact that it's distributed. The distributed nature of the brain itself is a major benefit of an octopus. And then so when we transfer this to AI and neural networks overall, I think that makes it a lot harder to paint the overall picture as to what exactly, how powerful are these neural networks compared to an octopus or a human or anything else, because there's too many factors that go into it. There's the structure of the brain, the shape of the brain, the number of neurons in the brain, etc. But we can see again that there's not direct correlations between some of these things, but beyond for example brain structure. But brain structure, there's a lot of correlation there. So when we examine and we look at, like, for example, neurons compared to structure, which one is more like beneficial overall for all of this, I would argue that structure matters more than neurons. But if we dive into the neuron debate overall, there's still questions that are to be answered there as well. So, for example, ChatGPT 4 is at roughly 1 trillion parameters, and then we can get a rough translation of essentially 100 parameters equals 1 neuron. So according to that logic, GPT-4 has about 100 billion neurons in its brain. So ChatGPT-4 has more neurons in its brain than a human does. Also, too, ChatGPT-4 doesn't have a body. I think that's a very significant aspect of all of this that people miss, is that that body, how much that body actually matters. So again, what we saw is that an elephant has the most amount of neurons in its brain out of any animal that exists on Earth. And the reason why it has so many neurons in its brain is because of its trunk. Like, look at the massive length and then also the function of this trunk. There's so much functionality that this elephant has, and then it's a entirely muscular structure. And then so that structure alone and that trunk structure of the elephant takes so many neurons just to power. So that's why the elephant has 200 billion neurons, because it needs all of that for just that muscular structure. But if you have an entity that doesn't have a muscular structure of any kind, doesn't have a central nervous system of any kind, doesn't need to power those things in a typical sense, then you free up those neurons to be whatever they want. So let's, again, going back to ChatGPT 4, which is 100 billion neurons, more than a human, but it's, again, it doesn't have a body, so you multiply that even more. And then what is the actual neuron capabilities of ChatGPT 4? I don't know. More than an elephant, like way more than a human. And then so then what that also begs the question of how low down do you go to start getting those capabilities again. Octopi are 500 million neurons, not a lot of neurons, and then octopi are very smart. So if you, the equivalent of 500 million neurons in this instance would be 5 billion parameters, which we can easily hit. So does that, or 50 billion actually, yeah, sorry. But so, which is again a reasonable amount and number to hit within that. So if you give it 50 billion parameters, is it as smart as an octopus? I don't know. Like, that's it, those are questions for debate. But what I do know is I examine all of this and I go through and I look through more at slime mold. I look at this box jellyfish. I don't think that it all comes down to like brain structure or specifics within the brain. Like, I think the brain itself is a computer, and that's its main function. I think that thought itself doesn't come from the computer. I think that thought is processed through the computer, not generated by it. And I think that's an important distinction here. And I think that we can see this all throughout nature. And then the more that we answer these more fundamental questions, the more it'll allow us to propel forward within these types of discoveries. And I think advance thought, advance science, and advance society forward. So if you like this type of content, please like and subscribe. Trying to make more like cerebral content, more kind of talking about subjects like consciousness, things like that, because that seems to be what people are most drawn towards. So if you like this type of content, keep it let me know and like and subscribe. Thank you very much.